So welcome everybody to Connect Recharge. I'm so excited to introduce our first round of speakers and to present to you today, Poojita Garg, who is a recent computer science graduate currently working as a research intern at Georgia Tech. She has 2+ years of experience developing mobile apps, and she has authored several technical publications and has been granted a patent for one of her inventions. She is a passionate advocate for women in technology and serves as a track evangelist for Women Who Code Mobile and a track lead for Women Who Code Python. When she is not a techie nerd, she is learning a new language, playing notes on her guitar, or even dancing on some beats. So without further ado, Poojita, I would love for you to take over.
Just a second. Actually, my phone's ringing. Just can you give me a moment?
Yes, of
I'll
course.
just turn it off. Thank you. Just a second.
Yeah, I mean, it said that you would dance to some beats and then your phone rang, and it was perfect timing.
Yeah. Sorry for that. Okay. Okay, coming back to the talk. So welcome everyone. Thank you, Mackenzie, for a wonderful introduction. And yeah, welcome to Android Sensors 101. So I'm Poojita, and I'm a research intern at Georgia Tech and also an incoming MScs student at Georgia Tech. And you can find my Twitter handle on your screen. And this is me giving my first in-person talk last week. So yeah, these are some glimpses of that. And okay, so where you can find presentation, so you can go on this link, which is bit.ly android-sensors.ppt, and also you can scan the QR code. So I will also provide this link again at the end of the slides. So a brief overview of what we are going to do today. So we'll start with introduction, then we'll move on to types of sensors, and then we'll go into depth about what is the Android sensor framework, and then how to test it with your emulator. Later on, we'll code 2 apps. The first one will be to find all the available sensors in your device, and the second one is the Luminosity Detector App. But before that, why this topic is interesting. So on the right, you can see me giving a talk about developing mobile apps for IoT devices. So I'm very passionate about developing, mobile apps for IoT and worked on various research projects. And this is the talk I've given in one of the GDG San Jose event, and also I've given for the mobile track of Women Who Code as well, the same talk. But lately I found out that there has been very interesting research happening to create like pocket-sized health monitors using mobile sensors. So using the powerful sensors, which are actually in your Android phone, like they are already embedded in that, we can use them to get data about different parameters, and then we can make an application that is very impactful and helpful. So some of the examples of such applications which I really liked were, like, you can see the Osteo app. So this Osteo app is an app for smartphones that tests bone density and tells the user whether they are at a significant risk for bone disease. So it uses the accelerometers on a handheld smartphone to measure your bone strength. So that's cool, right? Second, you can see is the HEMA app. So this is an app which uses the smartphone's flash and camera to illuminate the skin and provide the readings for hemoglobin levels. So these are some really good examples of how your own phones, hardware and sensors could be used to create some amazing applications. Okay, so without further ado, let's dive right into our today's talk. Okay, so let's start about this with discussing about the Android sensors. So most of the Android-powered devices have a built-in sensors that measure motion, orientation, and various environmental conditions. So these sensors are particularly capable of providing raw data with high precision, as well as accuracy, and are useful if you want to monitor, your device's three-dimensional movement or positioning, or any changes in your ambient environment near the device. So some of very cool examples which you have been using every day, is powered by these Android sensors. Like when you play a game on your phone, and so your game tracks the readings from the device's gravity sensor to infer complex user gestures like tilt, shake, rotation, or swing. So you can see on Subway Surf, which is a game I really love to play, and these kind of gestures we use these very frequently. The other example is the the weather application. The weather application uses your device's temperature and humidity sensor to calculate the dew point. Also, in travel applications, it uses your GPS and other sensors to calculate the position and stuff like that. So after you've got a little introduction about where and how these type of Android sensors are used, let's dive into what are the different types of such sensors. So the first one is the motion sensors. So these measure acceleration forces and rotational forces along 3 axes. This category includes accelerometers, gravity sensors, gyroscopes, and rotational vector sensors. The second category is in the environmental sensors, which help you measure the environmental parameters such as ambient air temperature, pressure, illumination, and humidity. So this category includes barometers, photometers, and thermometers. The third type of sensors is the position sensors, which help you find the physical position of a device. So this category includes the orientation sensors and magnetometers. Now, other than that, there are also 2 different categories of sensors. The first are the hardware-based sensors. So these are the physical components that are built into the handset or your tablet device. So this derives their data by directly measuring the specific environmental properties such as acceleration, geomagnetic field strength, or angular change. Software-based sensors are, on the other hand, are virtual or synthetic sensors. They mimic the hardware-based sensors, but they're not actually embedded in your device. So how do they work? They derive their data from one or more of the hardware-based sensors, such as linear acceleration sensor or gravity sensor, or even orientation sensor is one example of the software-based sensors. So here's I have included few of the popular sensors, their types, and their common use cases. And you can find a more detailed table on the Android developer guide. So one of the type is type accelerometer, which is very frequently used in different kinds of applications. It's a hardware-based sensor and is primarily used for motion detection, like shake, tilt of your device. Then there's other type that is gyroscope, which is again hardware-based sensor, which measures the rotation. Then there's a proximity type of sensor. So this is a hardware sensor, and this you have used every time you make a call. And when you put your phone near to your ear, then your phone screen gets disabled. This is due to this proximity sensor, that it senses that it's near to your skin, or it's near to your basically ear or face, so that it should not disrupt, perform any unexpected functions on your screen. So your screen gets disabled. So this proximity sensor helps to do that. Then you have light sensor, which is again another hardware category sensor, and which is used to control the screen brightness according to the ambience in which that device is being used. Then there's orientation sensor, which is a software type sensor, and it helps to determine the device position. So either it's in landscape mode or portrait mode, and so on. Okay. So the next question comes is how to use these sensors in your app. So for that, we use Android Sensor Framework. Now, it is part of your Android.hardware package itself, and it's not a third-party package. This helps you access the sensors and acquire the raw sensor data. This helps you to determine an individual sensor's capabilities, such as its maximum range, power requirements, manufacturer, etc. And it also helps you perform a variety of sensor-related tasks, like determining which sensors are available on your device, register, unregister the sensor event listeners, and also monitor the sensor changes, and so on. So now we'll dive deeper into this Android sensor framework, and we'll see all the classes and interfaces that it provides us with. So one of the class is Sensor Manager. So this is the class of Android sensor framework and is used to create an instance of the sensor service. So this is the first class which we are going to use while working with Android sensors. So this provides various methods for accessing and listing the sensors, registering and unregistering the sensor event listeners, and acquiring the orientation information. So this class also provides several sensor constants that are used to report sensor accuracy, set data acquisition rates, or calibrate the sensors. Another useful class of this framework is sensor class, which is used to create an instance of a specific sensor. This provides various methods that let you determine a sensor's capabilities. Sensor event used to create a the other class is sensor event, so which is used to create sensor event object, which provides information about a sensor event. A sensor event object includes the following information: the raw sensor data, the type of sensor that generated the event, the accuracy of that data, and the timestamp for the event. The next is an interface which is provided by a framework, which is Sensor Event Listener. Now, this is used to create two callback methods that receive notifications when the sensor value changes or when sensor accuracy changes. So these two callback methods are namely on accuracy changed and on sensor changed. So on accuracy changed is called when the accuracy of that registered sensor is changed, whereas on sensor changed is called when there is a new sensor event. So when a sensor's accuracy is changed, in that case, the system invokes this on accuracy changed method, providing you with a reference to the sensor object that changed the accuracy of the sensor, and the second one, which is on sensor changed, in that case, the system provides you with a sensor event object here. The next is testing your application, which includes this, uses these sensors with the Android Emulator. So I usually, when I make mobile apps, I usually use Emulator for testing my apps. So there's also a way to, because since it's a virtual device, so it will contain some virtual sensors. So there's a way to where you can access these sensors on your emulator and also test them. So if you go to your emulator and there are like 3 dots, you click them and this kind of window will open. On the left menu, you can see that there is virtual sensors. And here you can test your device according to the different values. You can rotate, you can move, and so on. And here you will find the accelerometer values, gyroscopes values, and magnetometer values. Also, there are additional, additional sensors which are also there. And on the top, you can see there's a tab for additional sensors. So on clicking on that, you'll find additional sensors like proximity, light, humidity, pressure, and so on. Okay. So I hope this introduction to all the types of classes and interfaces for the framework are clear. Now we'll move on to coding. So first app which we are going to create today is to find all the available sensors on the device. So this will be a basic app which shows the list of all the the sensors which are there on your device. So this is the output which you will get if you test it on the emulator. So these are the sensors which are present on my emulator device. Okay. So in this, we will, in our main activity, here we have the first line, which is the sensor manager. Here in this, first of all, we will create an instance to the sensor manager class, and that here we are calling it manager. In this, then we are referring it to get the system service. So this first line will give you a reference to the system service, and this is the way to do that. Later in the next line, here we are fetching it in form of a list. So we are using another function, which is get sensor list of the sensor manager, and also fetching them, storing them in a list of sensors. In its argument, we are saying type all. That means we have to find all the sensors which are available on the device and not leaving any. But if you want to find, the sensors which are accelerometer, then you can have type accelerometer here. So this is like we can have any, you can find the list of any specific or in general all the sensors. Later on here, we are just making, appending it in a single string so that we can set the text of the text view, which we have created in the XML file with the list of all the sensors available. So for that, we are using the string builder here. First of all, we are just appending a simple, line about like sensors on this device, R, colon, and later on, we are using a for loop to fetch individual sensors in this list, and we are then appending each and every while we are traversing the for loop into this message. Later on here, we are just setting our text of the text view to be that message. So this will give you this result. Also, you can scan this QR code here to get a direct link to my GitHub, where I've posted the code for this application. Okay, so once this is done, now we'll go to our Luminosity Detector app. Now in this app, we'll go one step forward, and we want to show the value of the light sensor. So we'll show the specific value of a specific sensor, if for our case is a light sensor. We'll also change our background of the application according to the luminosity detected by that light sensor. And later on, since we were showing the value of the light sensor as well in the text, we will change its color depending upon the background which is changed. And this is the demo of this application. So as I increase the light sensor value, so there's more light detected. That means your app background should get brighter. So you can see the value as well, and the screen is getting brighter. Also, notice that the text color, is also changing. And when the light sensor value is less, our background is black or is darker, and also our text color is like suitable to the background. Okay, so I hope you're all interested in making this app, right? Let's dive into its code. So for this, we'll start again with our main activity, and we have declared few objects of the sensor framework classes. Here of the sensor manager, sensor, and text view, and few variables as well. Coming to our onCreate method. First of all, let's see what this implement sensor event listener means. So if you remember, I told you that the sensor event listener is an interface of our framework, right? Android sensor framework. So this main activity is right now implementing our sensor event listener, which will also create our two callback methods, which we discussed earlier, which is the on sensor changed and on accuracy changed, which we are going to discuss in a bit. Okay, so let's first start from this first line of code. Here we are just giving it a reference to the UI component. And now again, we are using the mSensor manager object, and we are giving it a reference to the system service by using the get system service function, which is same as the previous one. Later on, we are also referring the mSensor light variable to get the reference to the default sensor of type light. So this this function of get default sensor is used to fetch the default sensor of the type which you have specified here. So because in your device there can be multiple sensors with the same type, that's why, but we need to fetch single. So for this, I have used the get default sensor. Later on in this if condition, I'm also checking that if our sensor is null, then our app should return a sensor error, which I'm fetching in this from my string. So if null, we display an error message. Okay, coming to the onStart method. In onStart method, we have to register the listener, and we have to also make sure that it's not null. So we already did that as well, but sometimes if we forget doing that earlier, it's a good practice that when we are registering the listener, we should definitely check. We should definitely, use an if condition there to check that if the sensor reference is not null. So in this if condition, we are doing that, and later on, we are using the .register listener method on the sensor manager, and we are registering the sensor listener. Also, in one of its argument, we are specifying a sensor delay. So this is the data delay that controls the interval at which the events are sent to your app. So the delay at which you want the next reading of your sensor to be, to be sent to your application. So that's controlled by this sensor delay. So here there are multiple values of it, and I have used in my application it as sensor delay normal. In the next line, we are just calculating, we are just fetching the maximum range of the sensor, which we are going to use it later on. The next in the onStop method. The onStop method is here we have to unregister all our sensor listeners. So we are doing this by a simple method, which is unregister listener. So this is very important step. Sometimes we forget to do the step of unregistering the listeners, and that can actually drain your device's power very substantially. So because many of these sensors use a lot of power and also other device resources. So when the application is on stop, we don't want the sensors or the application to be using the device resources. So for that reason, we have to unregister the listener here. So also there's another point here that sometimes we may also register or unregister or on pause or on resume pair of the code. But that's not advisable because, in certain cases, like a multi-window type system, so when your application is on one part of the window, there it's on pause state, but you still might wish to see the sensor readings if they are changing, right? But if you will unregister your listener on the on pause state, then you might not get good results there. So it's better if you have this register and unregister phase in the on start and on stop functions. The next is that we are on the on sensor changed method. Now here, first of all, in the current value, we are fetching the sensor events value, so the sensor's value, and on the 0th position. Sorry. So the sensor might send more than one values, So the 0th value will have the actual value and more than one parameter, sorry. So in the array, it may have more than one parameter, like maybe accuracy or maybe manufacturer, maybe something else. So, but we have to fetch, we have to fetch the one with the 0th index value. Now, next is the new, we are finding out the new value. Now, in this new value, why we are finding out this new value is that we have to transform the light sensor value, which we are getting in the current value, to be between the maximum range of the decimal color. So for that, we are using this formula of this formula so that it is between the range of 0 to 255, which is the range of decimal color, because we have to later use it into setting the background color. You can see in the next line, we are setting the background color of a root UI element, which we have defined in the XML file as this. So we are using the new value to set the background color. So this is the half thing done. Okay, now we have fetched the value of the light sensor. We have also set the background color. Now the last thing is left is to change the font color, the text font color. Now for that we are calculating another set of this value, which is luminance. So now this is the perceived luminance which you are perceiving through your human eye on of that application. So since we have a background color, so you are perceiving this background color. So this is like this is the formula which I have used to find out the luminance. This is the standard formula. Later on, I'm doing two things. I'm first of all setting my text view to show this label, so which I have already created in the strings. So this is the label and the current value. So now our text view will show the value of the light sensor. And the second, we have to change the text color. Now for that, I'm using a threshold of 0.5, that if the luminance is greater than 0.5, then like change the text color to be black. That means there's a brighter background and your text needs to be the complementary color, which is black. And if the background is in dark colors, then white will do. So the text color should be white or light color. Okay, so this was all about the on sensor change. Now we have the on accuracy change. So since this is the second of the two callback methods. So on accuracy change, some little facts about it. So this is called when the sensor accuracy changes, and the sensor object identifies the sensor that changed the accuracy. There are different levels of accuracy, right? So this is like sensor status accuracy low, sensor status accuracy medium, and high and unreliable, and no contact. So these are certain different levels of accuracy. But for our application, we are not concerned about the accuracy change of the sensor. That's why we are leaving it blank for now. Yeah, so let me just fetch the app once again to show you the output. So after going over this code, this is the final output. So our background is changing as well as the value and also the text color. Okay, awesome. I hope the code is very clear. So I've kept it fairly simple and fairly basic. Now let's talk about some of the best practices. So when we're using sensors in our application, some of the best practices include, so the first thing is to unregister your sensor lists. So this is an important step, and we have to take care of it at all times, that we that we change this, like we always unregister the sensors. Just a second. Okay, so the next is avoid using depreciated methods and sensor types. So there are certain sensor types which are depreciated, and they're all given in the Android developer guide for the sensors. Like one of the example is type temperature. So that is depreciated, and instead of that, you have to use type ambience temperature, so something like that. So you should go through the guide once, and you'll find all the depreciated methods and sensor types there. The next of the best practice which you should use while developing is to verify sensors before you use them. So this is very important because sometimes we know that these sensors are very frequently used, and we don't verify them, and we directly use it in your application, but that might not be available on your device. So you should always first verify that if these sensors are available on your device, and then only start to code or use their data values to perform some tasks. The next is to choose the sensor delays carefully. So these data delays which are which you have to provide, you have to choose them carefully. So this will depend upon the kind of application you're creating. So if you're creating a gaming application, then it will have a different sensor delay. And if you're creating some other like travel application or weather application or something like that, then it will have a certain, it will require a different sensor delay. So also be careful about what kind of delays you choose. So sometimes whatever delay you choose, it's not necessary that our application would use that delay only, but that's the maximum limit which you give. So you have to find out the maximum data rate by which you want your next value of the sensor should be fetched, and your app still works fine. So you have to decide that and give the code that value. So the application or the device would actually choose the value which is less than or equal to that delay given. So choose it wisely. The next best practice is that don't block the on sensor changed method. So sometimes we tend to write lots of lines of code in the on sensor changed method only, and that will block the on sensor changed, because this will work every time a new data value is received by the on sensor changed method, and that might be very fast. So avoid putting all the lines of the code inside the on sensor change. So in the application we did today, it was just very few lines of code and just one or two activities which we were performing, and a fairly basic kind of application which we were making. But when you are making a full-fledged application with lots of parameters involved, then try that most of your code is in some different function, and in on-sensor change, you're not blocking it. Yeah, so these were some of the best practices. So I guess well done. You are now all set to using the sensors in your next Android app. So with this, thank you so much for attending the talk today. And here you can here you have the link for the presentation again. And also, if you want to read more about Android sensors, you can go to the Android Developers Guide for it. And it is like really good place to start using Android sensors. So yeah, now I'm open for questions.
Yeah, it looks like you got some questions in the chat. So the first one is, from my understanding, will all Android phones have the sensors embedded?
Yeah, so all the modern Android devices have most of the sensors embedded, and very powerful too. So, but you have to check for the particular sensors you want to use.
And then the next question is, how would you call a specific sensor by name? For example, when you have multiple sensors of type light.
Okay. So if you have multiple sensors of the same type, then you have to, traverse through the list of those sensors in your code once and see, like print them and see which one you want. And then you can choose that type of sensor.
And then also from the same audience member, I think I missed where max value is defined. Is that a value that you can grab from the sensor?
Yeah, so the max value constituted the maximum range. So we fetched that using the function called get maximum range from that sensor value. So in that we were, that was a variable where we were storing that value of maximum range, which we have later used in the on sensor changed method. Welcome.
Thank you. We have a few more minutes if anybody else watching has any questions for Poojita. Please post them in the chat, and you can also reach out to her. It looks like she posted her website and then also her handle on Twitter as well. Thank you so much for your presentation and for everything that you prepared. Really
Thank
great.
you so much, Mackenzie, and each and every one of you to attend my talk. I hope it motivated you to use Android sensors in your next application. So yeah, let me know. You can connect with me on Twitter. My handle is there, or you can visit my website as well. Or it will have all the methods to getting in contact with me, and let me know what you created with the Android sensors.